Welcome back to Leshire Math. This is question 5. On question 5, this is what we are going to do. You're told that the table below shows values of x and y for the curve C with the equation y is equals to f of x. So we are given the values of x and y. Then part A, you're told using the trapezium rule, will all the y values in the table find an estimate for the area of the region bounded by C and the x-axis between the lines with equations x equals to 0.1 to x equals to 5.1. So in this case we have two figures. We have figure 1 and figure 2. Then you're told that figure 1 shows a sketch of solid concrete skateboard ramp. Figure 2 shows graph of the cross section of the same ramp. The ramp has a total length of 6 meters, has a platform each end at a height of 1.5 and with a length of 0.9 meters, has a curved section C with the equation y equals to f of x, where x and y are in meters, has a uniform cross section and is 2.5 meters wide, as shown in figure 1 and or figure 2. So part B, using answer to part A, find an estimate for the volume of concrete in the whole of the ramp. Then part C, state giving a reason for your answer, whether the answer for part B is an overestimate or an underestimate of the true volume of concrete in the whole of the skateboard ramp. Now we can start with part A. Part A, they are saying that using the trapezium rule with all the y values in the table, find an estimate for the area of the region bounded by C and the x-axis between the lines with the equations. So this is what we are going to do. Just to scroll to the spacing. So part A here, first we are required to determine the height, and your height in this case will be the difference between two consecutive terms. You can have 1.5 minus 0.9, and this one gives 0.6. And we know by trapezium rule the area is given as a half multiplied by h, open the bracket, the sum of the endpoints, that is y naught plus yn, then plus 2 times y1, the middle values, y2, y3 plus yn minus 1. Now if we substitute this based on the values we have in the table, we'll say that area here will be equals to a half, of course, times 0.6, open the bracket. The endpoints in this case you are given as from what we have up there, we have 1.5 plus 1.5, then plus 2 into the remaining middle values, the 0.8 plus 0.30 plus 0.26 plus another 0.26 plus 0.30 and plus 0.48. So simplifying this further, we can say that this one equals to, of course, half times 0.6, this gives you 0.3, then open the bracket, we can have our calculator here. So 1 will have 1.5 plus 1.5. This gives you 3. So we'll have 3 plus the second bit. We can also have 2 into 0.48 plus 0.30 plus 0.26 plus 0.26 plus 0.30 plus 0.48. Then we can close the bracket and find what is your solution here. So this one is 4.16. So when we add the two, then this means we'll have 0.8 plus 0.3 plus not plus but multiply by 0.3 into the sum of these two. So plus 3, you answer plus 3. This gives you 7.16. And if we multiply that answer by 0.3, your solution here is 2.148, of course cubic, not cubic meter but square meters, because we are dealing with the area. Now since remember, for pure mathematics 2, all the solutions are supposed to be expressed to 3 significant figures unless otherwise, and therefore this is what we are going to have: 2.15 square meter as the area of the curved surface C by trapezium rule. Now if we look at, we can also consider part B, and part B I will want us to sketch, because there's something I want you to see here. So if we look at part B from the diagram up here, part B says that after giving all this information, using the answer to part A, find an estimate for the volume of the concrete in the whole of the ramp. Now I want us to consider the second diagram, and in this second diagram already we've been given the area under the curve, C. So already this one we have. And this one is what we have as 2.148 square meters. But if you look at this, the far ends, on the left hand side we have a rectangle, and also on the right hand side we have a rectangle. So for us to get the volume of concrete in the whole ramp, and remember volume is the area of the cross section times length. So first we need to get the total area of the cross section. And if you look at this keenly, is that the other ends are a rectangle, and the dimensions of this rectangle will have 1.5, and this one is purely 1.5 times this one is 0.9, and also this one is 1.5, and this one is 0.9. So what we are going to do in this case, first we know that volume is simply equals to cross sectional area multiplied by length, and the cross-sectional area in this case. So let's start with getting the cross-sectional area. Already the area under C, we've determined by trapezium rule. That is what we are given up here. So we've estimated the area bounded by C and the x-axis, and between the lines 0.9 to 5.1. So that one we've estimated. So what remains, we want to get the area of the rectangular parts on the left hand side and on the right hand side. So this means that since there are two rectangular endpoints which are the same, this one will be the same as 2.148. Let me write this 8 properly. 2.148 plus 2 multiplied by, we know that the area of a rectangle is given as length times width, so this one will be 0.9 times 1.5. 0.9 times 1.5. Now simplifying this further, this one will be just the same as 2.148 plus, let's have our calculator, 2 into bracket 0.9 multiplied by 1.5. So this gives you 2.7. 2.7. So we'll add this one to 2.7. And what is 2.148? So we'll have answer plus 2.148. What does it give you? It gives you 4 point. So your solution here, the area of the cross section is simply 4.848 square meters. So using this, we can say that therefore the volume is simply equal to cross-sectional area times length, and the cross-sectional area is 4.848 times length, which is 2.5, because that is what we are given up there. And when we get the product of this, we'll have answer times 2.5, and this one simply gives you 12.12. So this one will be equals to 12.12 cubic meters. And since you're supposed to express your answer to 3 significant figures, then this one is the same as 12.1 cubic meters. And this becomes the solution for B. That is the volume. The volume as required. Now, we can also consider the last part C, and the last part C says that state, giving a reason for your answer, whether the answer for part B is an overestimate or an underestimate of the true volume of concrete in the whole of the skateboard ramp. Now, what are we supposed to do in this case? Is the area overestimate or underestimate? If at all we can consider two things based on what we have. Majorly, the estimate itself is an overestimate because the total area of the trapezia is greater than the actual shaded cross-sectional area under the curve. Therefore, the estimated volume is simply greater than the true volume. So the reason we can give here, we can say for part C, we can say that the estimate is an overestimate Why? Since the curve is concave upwards, so the trapeziums lie above the curve. So this is just one of the reasons you can give, or you can say that or another reasoning we can give, or we can also say that the estimate is an overestimate. Why do we say so? Because the total area of the trapezia is greater than the actual shaded cross-sectional area under the curve. So with this, we can also say that therefore the estimated volume is greater than the true. Give you the score for part C. The only question we can have for that is saying that the trapezia are bigger than the cross section. No, but all these two reasons will be regarded as true.